Welcome! In this video, we will explore Python comprehensions. Comprehensions are an elegant and concise syntax for creating lists, dictionaries, and sets in Python. We will look at list comprehensions, dictionary comprehensions, and set comprehensions. As you can see in the example, instead of writing a traditional for loop to generate a list of squares, we can achieve the same result in a single line using list comprehension. Here's the basic syntax for list comprehensions. The syntax consists of an expression followed by a for loop that iterates over an iterable. The expression is evaluated for each item in the iterable, and the results are collected into a new list. Let's look at some examples. The first example creates a list of squares for numbers from 0 to 9. The second example creates a list of characters from the word Python. Note how each element in the list is created based on the expression provided. Let's explore some more practical examples of list comprehensions. In the string manipulation example, we convert a list of names to uppercase using the upper method. In the data transformation example, we extract the first character from each word in a list. In the calculation example, we convert Celsius temperatures to Fahrenheit. Finally, in the working with tuples example, we extract the second item from a list of tuples. These examples demonstrate the versatility and conciseness of list comprehensions. List comprehensions can also include conditional logic to filter or transform items based on certain conditions. The first syntax shows how to include an if condition to filter items. The second syntax demonstrates how to use an if-else condition to transform items based on a condition. Let's look at some examples. The first example filters a list of numbers to include only even numbers. The second example transforms a list of numbers to indicate whether each number is even or odd. This conditional logic adds more power and flexibility to list comprehensions. Now let's move on to dictionary comprehensions. The basic syntax for dictionary comprehensions consists of a key expression and a value expression, followed by a for loop that iterates over an iterable. The key expression and value expression are evaluated for each item in the iterable, and the results are collected into a new dictionary. Here's a comparison between the traditional approach and using dictionary comprehension to create a dictionary of squares. The dictionary comprehension provides a more concise and readable way to achieve the same result. Let's explore some examples of dictionary comprehensions. In the word length mapping example, we create a dictionary that maps each word in a list to its length. In the swapping keys and values example, we create a new dictionary by swapping the keys and values of an existing dictionary. These examples demonstrate how dictionary comprehensions can be used to create dictionaries in a concise and readable way. Next, we'll dive into set comprehensions. The basic syntax for set comprehensions consists of an expression followed by a for loop that iterates over an iterable. The expression is evaluated for each item in the iterable, and the results are collected into a new set. Similar to list and dictionary comprehensions, set comprehensions provide a concise way to create sets. Here's a comparison between the traditional approach and using set comprehension to create a set of squares. Set comprehensions offer a more streamlined way to achieve the same outcome. Let's explore some examples of set comprehensions. In the unique characters example, we extract the unique characters from a text string. In the filtering with conditions example, we create a set of even numbers from a list, filtering out duplicates. These examples showcase the utility of set comprehensions in creating sets with unique elements and applying conditional filtering. For more complex transformations, you can nest comprehensions. This allows you to iterate over multiple levels of iterables and perform more intricate operations. Let's look at some examples. In the flattening a matrix example, we transform a 2D matrix into a 1D list. In the creating a matrix example, we create a grid of coordinate pairs. Nested comprehensions enable you to handle more complex data structures and transformations with ease. To wrap up, Let's discuss some best practices and performance considerations when using comprehensions. Keep comprehensions simple and readable to maintain code clarity. Avoid complex logic inside comprehensions to prevent them from becoming too convoluted. For large datasets, consider using generator expressions, which are memory efficient and generate values only when needed. Use meaningful variable names to enhance code understanding, and add comments for complex transformations to explain the logic. Additionally, generator expressions, created using parentheses, are memory efficient for large datasets as they generate values only when needed, making them suitable for big data scenarios. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.